All right, so in this video, I'm going to teach you guys how to sketch polynomials. And even though you have Desmos to help you verify your answer, you still have to know how to do it by hand. All right, so what was the whole point of this multiplicity, right? I basically said multiplicity is how many times a zero occurs. Why is that significant? Because it determines, what happens or the behavior at the zeros for your graph. So, for example, if you have a multiplicity of 1, it means it's going to cross at the x-axis. Okay, a multiplicity of 1 crosses at the x-axis. And what do I mean by that? So if I give you a quick graph in intercept form, right? You have x minus 1, x plus 2. Well, your zeros are going to be located at 0, 1, and negative 2, right? 1 and negative 2. And the graph's going to look something like this. Right? So notice at these zeros right here, they're all crossing. Okay, crossing at 1, crossing at 0, and crossing at negative 2. And the reason why is, right, the multiplicity here is a 1, right? This is a 1, this is a 1. Okay, so multiplicity of 1 crosses. And in general, okay, odd multiplicities also cross at the x-axis. Well, why did I have a separate one, right? If all odd multiplicities cross at the x-axis, well, I'm going to use a different word instead of crossing. It flexes, okay? Flexes and cross basically means the same thing, but it looks slightly different. Okay, so what do I mean by odd multiplicity flexes at the x-axis? So if I were to give you, I don't know, take this graph for instance. F of x is equal to x plus 5 cubed times x minus 3 to the 5th, right? Would you agree that the zeros right here are, the multiplicities are all odd, right? 3 and 5 are all odd. So what does the graph actually look like? Well, it's still going to be crossing, okay? Here's negative 5, here's 3. Those are my multiplicities. But when you look on Desmos, the graph's going to it's going to kind of hug the x-axis, if you will, right? It's not... it's going to cross eventually, but it kind of hugs the x-axis. So that's another way of saying flex, right? This is what a flex looks like. Okay? So odd multiplicities and, multiplicity of 1, they all cross the x-axis, but odd multiplicity, I would say, of 3 or higher, all right? Because, 1 is an odd number, right? But 3 or higher. And that's what you have over here. All right, so odd multiplicity cross at the x-axis or 3 or higher flexes. And the very last possibility is that even multiplicities bounce at the x-axis. Okay, so what does a bounce look like? Well, you already graphed this function before, f of x. How about we just give you a basic quadratic function, x minus 2 squared, right? Would you agree that this is an even number, right? Even multiplicity. And if I say graph at the x-axis, you would say the vertex is at 2, 0, right? It does not cross, it bounces. Okay, so that's true for any even multiplicity of a particular zero. All right, so in summary, how would you graph? Well, you're going to connect everything you've learned in the beginning of section 2.2. You're going to use LC test, okay, leading coefficient test, to determine your M behavior. You want to find the zeros. And multiplicities, okay? So that implies that you need it to be in factored form, okay? So it has to be an intercept form for you to determine the multiplicities, right? That's why I wrote in the notes, for instance, x squared plus 5, I wrote as x plus root 5, x minus root 5. It's to determine the multiplicity. All right, and you also have this tried and true method of plot additional points and find y-intercept if there is one. And then the last step, of course, is to sketch. Okay, so I'm going to use these 4 guidelines in the next video, which I will do some examples.